Most water is colorless, tasteless, odorless, and fairly commonplace. We should not, however, be fooled by the ordinariness of water, for as a chemical, it is extremely unusual. Water possesses great stability, is a powerful solvent, and provides an excellent medium for chemical reactions. Water can absorb and release more heat than almost any other substance, and it exhibits certain strange characteristics upon heating and cooling. In most aspects, water is an oddity, an exception to the normal rules of chemical behavior. And in every respect, these oddities have become woven into the web of life on our planet. The chemical formula for water is one familiar to us all, H2O. This means that a molecule of water contains 2 atoms of the element hydrogen and 1 atom of the element oxygen. The chemical bonds between the hydrogen and oxygen atoms are very strong, and tremendous energy is required to break them. For this reason, water is a very stable substance. The uneven distribution of electrical charges between the hydrogen and oxygen atoms creates a molecule with a lopsided shape, which behaves like a chemical magnet. The negative portion of the water molecule attracts positively charged materials, and its positive portion attracts negatively charged materials. This property allows water to easily dissolve a wide variety of chemical compounds. Without this ability, the intricate biochemical processes of life would not occur. For example, the transmission of nerve impulses depends on electrical conductivity, and water itself is a poor conductor of electrical current. But when salts are dissolved in it, it becomes a good conductor of electricity, as is demonstrated here by the rapid drop in resistance to electrical flow, which occurs as salt is dissolved in pure water. Another unusual property of water is that in its solid state as ice, it is lighter than liquid water. Most liquids become increasingly dense as they cool and will sink as they solidify. Water does in fact become denser as it cools. However, at 38 degrees Fahrenheit, it begins to expand with the result that solid ice occupies a 9% greater volume than liquid water. The effects of this property on some of Earth's creatures are surprisingly great. Floating ice acts as insulation to the liquid water below, allowing aquatic life to survive during extended periods of extreme cold. If ice became heavier than liquid water, it would sink to the bottom, causing the seas or lakes to freeze solid. If this were to happen, tremendous climatic changes would occur, making it much more difficult for life to survive. Another remarkable property of water is its heat capacity. That is, its ability to hold and release large amounts of heat. A large amount of energy is required to raise the temperature of water even a single degree. As a consequence of this large heat capacity, tropical seas absorb tremendous energy and become vast reservoirs of heat, which is slowly dissipated as the ocean currents head into the polar regions. In this way, the heat capacity of water moderates the effect of sudden and drastic temperature changes in the Earth's climate and helps life flourish on our planet. As a result of the strange effect known as latent heat, water gives up a large amount of heat simply by changing from a liquid to a solid, as happens during freezing. This property is put to use in some orchards, where blossoms are sprayed with water when they're in danger of destruction by frost. The heat given off by the freezing water can actually prevent serious crop damage, as long as the air temperature does not drop too far below freezing. Likewise, as ice thaws, It absorbs warmth, causing heat to be extracted from surrounding objects such as food stored in a cooler chest. Similar examples of heat absorption and release are observed as water changes from liquid to a gas, and upon condensation as it changes from a gas to a liquid. It is the latent heat of the water in our atmosphere that creates weather patterns and provides the powerful energy of thunder and lightning storms. The effects of latent heat, heat capacity, and the ability of ice to float can all be traced back to the lopsided nature of the water molecule, resulting from the unequal distribution of its electrical charges. In addition to the properties derived from its internal atomic bonds, water has certain characteristics resulting from its ability to form weaker links, called hydrogen bonds, with other water molecules, and with a variety of more complex molecules. Hydrogen bonding creates the skin, which exists on the surface of water, which is strong and elastic enough for small insects to walk on. And it is this surface tension which causes water to fall in separate drops. In another effect called capillary action, the hydrogen bonds between the water molecules and the molecules in this glass tube allow the water to pull itself up against the downward force of gravity.